In this video, we are continuing our application problems, solving linear equations, but this time we're going to be solving problems involving relationships among two unknown quantities. These are sometimes called comparison problems because you are going to be comparing two things algebraically. So comparison problems. These are definitely harder, but they do follow sort of a prescribed method. So if you'll just hang with me for a couple, I think you'll get them. It says last month Sheila worked 72 hours more than Russell. This one kind of sounds like the last one, doesn't it? Together they worked a total of 232 hours. Find the number of hours each person worked last month. The key here is figuring out who is the base person. So when I talk about Sheila, I describe Sheila in terms of Russell. So Russell is the base. So we're going to say, let X equal Russell's hours. I'll abbreviate. And the second thing we have to know, so these comparison problems are always going to have at least two let statements. We have to be able to talk about Sheila's hours, and it's going to be in terms of Russell's. And what it says is Sheila worked 72 hours more than Russell. So 72 more than Russell. Russell is X. So now I have my two let statements. That's actually the hardest part of these comparison problems. Next, the problem is going to give me one more piece of information that will help me to make my equation. And what it says is together, meaning add, they worked 232. So I'm going to write what I call an organizing statement, and that is this: Russell plus Sheila equals 232. Isn't that true? And now I'm going to substitute what my let statements told me represent Russell and Sheila. So Russell is X, because I said so, plus, what is Sheila? 72 plus X. So it's not just X plus 72, it's X plus 72 plus X. So with color, let me show you. This is Russell. This is Sheila. And we know that their total is 232. And now I have my equation, so I'm going to go through my steps. There's no fractions, no distributive property, but I do have like terms to combine. So 2x plus 72 equals 232. Variables are on the left, so let's get the numbers on the right by subtracting that 72. 2x is equal to 160 when you subtract. Last step is always to divide. And I get x equals 80 hours. Now, we're not finished just because we got the x, because I had two let statements, I have to have two answers. So who worked 80 hours? Who's x? Russell. So 80 hours for Russell. Now how do I find the hours for Sheila? We go back to our let statement, and it's 72 plus whatever we found for X. So it's 72 plus the 80 that we found for X, giving me 152. So 152 equals the hours for Sheila. So you actually have two answers, Russell's hours and Sheila's. And that's the way a comparison problem is always going to be. You're going to have at least two answers unless there's three things being compared. Then you'll have three answers. So let's look at another one. Remember here that the hardest part is determining what is the base. So it says the attendance at the Saturday night baseball game was 3 times the attendance at Sunday's game. So the base here is Sunday's game because Saturday is described using Sunday. In all, meaning add, 56,000 fans attended the games. So we're going to say let X equal the number at Sunday's game, which means that the number at Saturday's game comes from the words of the problem. The attendance at Saturday night was 3 times the attendance of Sunday. So 3 times X. There are my two let statements, and now we need that last piece of information to get our equation. I know that Saturday plus Sunday equaled 56,000. That's my organizing statement. Saturday is 3x plus Sunday is x equals 56,000, or 4x equals 56,000. And now the only thing left to do is to divide by 4. And we get x equals 14,000. And what did x stand for? Go back to your let statement, Sunday's game. At Sunday's game. And how do we find Saturday's game? At Saturday's, we do what it says right here. We multiply x by 3. So we take 14,000, we multiply it by 3, and we get 42,000 at Saturday's game. You can check those by adding them together and making sure they make 56, which they do. So again, that's a comparison problem. Let's try another one. I think this one is harder. Riley cut a cord that was 83 feet long into 2 pieces. All right, so I'm going to draw this cord. Here is a cut. I don't want to make them even. And I know that all together it was 83 feet. The second piece was 19 feet shorter than the first piece. So what's my base? When you see that word than, what comes after it is your base. So let x equal the first piece. So now we have to describe the second piece in terms of the first piece. What does it say? The second piece was 19 feet shorter than the first piece. Now you got to think about it. Is it 19 minus x, or is it x minus 19? To be shorter than something, you have to have the something first. So it's x minus 19 is the second piece. What do I know? I know that the first plus the second, this is my organizing statement, equals 83. And now I'm just going to fill in. So my first is x, my second is x minus 19, and my total is 83. So here's the first, here's the second. Notice it's not just x minus 19. That doesn't make sense. All right, I'm now going to combine like terms. So 2x minus 19 equals 83. I'm going to add a 19 to both sides. So 2x equals 102. We divide by 2. Let me move this up so you can see what I'm doing. We divide by 2, and I get x equals 51 feet. Now what is x? Go back up to your let statements. X is my first piece, and I know that it is 51 feet. How do I find the second piece? It tells me right here, 51 minus 19. So my next piece is 32 feet. Add them up, and it checks. It makes 83. All right, the last type of problem that we're going to do is also a comparison problem, but it has to do with rectangles and perimeter. So let's look at this the last two problems on your notes. Number 7 says the length of a rectangle. So before I go any further, I'm going to draw a rectangle because you want a picture on this one. I'm going to label length and width because my problem is going to talk about those two things. And it says the length is, that means equals, 2 more than the width. So I'm going to translate that right onto my picture rather than writing a let statement. The length is 2 more than the width. That's what it told me. It doesn't tell me anything about the width. The perimeter, it does tell me the perimeter is 68. Find the length and width. And then it says use this formula. So once you have your picture labeled, you're going to write the formula. P equals 2L plus 2W. And now for each of my variables, the P, the L, and the W, we're going to fill in anything that we might know. So what do we know about P? We know that it's 68. Copy down the 2. What do we know about L? This. So it's going to be 2. Take out the L, put in its substitution there. Write your 2. What do we know about W? Nothing. So we leave it. And we now have an equation that can be solved starting with, there's no fractions, the distributive property. So 68 equals, distribute that. I distributed, and then don't forget the second one. Combine like terms, so 68 equals 4 plus 4W. Get variables on one side, so I'm going to subtract that 4. And I have numbers on the other side, and now divide by that coefficient, and I get that the width is equal to 16 centimeters if you do that division. Now that's not all though, I also have to know the length. The length is equal to 2 plus the width, so it's equal to 16 plus 2, which is 18 centimeters. So I'm still getting 2 answers in the 2 pieces that I am comparing. Let's do another one that's just like that. And if you want to pause the video and try it on your own and then start it again and check it, that would be a good idea. The perimeter of a rectangular house is 122 feet. We're going to draw that perimeter first of a rectangle, label L, W, perimeter 122. So I wrote down what I know. It's going to tell me something. The width, so this is telling me about the width, is 5 feet less than the length. So it's the length minus 5. That's the one it told me about. My next step, remember, was to write the formula 2L plus 2W. That's the perimeter of a rectangle. Fill in the parts you know. Perimeter 122. 2, I know nothing about L, so I leave an L. 2, I do know something about width, so I take that out and put in L minus 5. Now we're going to distribute, so 122 equals 2L plus 2L minus 10. We're going to combine like terms on the right, and now I'm going to move the numbers to the left because the variables are taking up the right side. Divide is our last step, and we get L equals, if you divide that, 33 feet. So I know that L is 33 feet. The width is, go back to your picture, L minus 5, so it's 33 minus 5, or 28 feet. And I have the 2 pieces in my comparison problem.